Hello, this is Mr. Miller. Welcome to video 2E, Limits Involving Rationalization. So these are some special limits that involve a trick with square roots. All right, let's get started. First, I want to talk about two nice examples and then one that's a little bit tougher. All right, the first two are nice because we don't have to do any tricks. In this first one, as x approaches 1, the numerator is approaching square root of 1 minus 9. And the denominator is approaching 1 plus 3. Square root of 1 is 1. So in the numerator, I get negative 8. And the denominator 4, which is negative 2. Actually, so the limit is negative 2. It was in a nice part of this function. Okay, the denominator wasn't approaching 0, so there was no issue. Same thing here, as x approaches 4, the denominator is not approaching 0. This limit is going to be okay to evaluate. So if we just substitute 4, we get square root of 9 minus 2 times 4, all over 4, which is the square root of 9 minus 8 over 4. All that's in the square root. That's the square root of 1 over 4, which is just 1/4. No problem. Again, we were in a nice area of the function. It wasn't in a part where the denominator was 0. However, here comes the problem. In this one, as x approaches 4, we see that the numerator is approaching 2 minus 2, which is 0, because the square root of 4 is 2. We have that minus 2. And the denominator is approaching 0 also. 4 minus 4 is 0. So both the numerator and the denominator approaching 0, we have to do something. Okay, so we're going to try to rationalize the numerator. Okay, so this is how we do that. So this is equal to the limit of square root of x minus 2 over x minus 4. That's what I have already. And here's the trick. We're going to multiply by the conjugate of the part with the square root. So the conjugate is the same expression, but with a plus. If this is minus, the conjugate has a plus. And if this is a plus, the conjugate has a minus. But we have to multiply the numerator and the denominator by the same thing. Okay, looks like a big mess, but it's going to work out okay. So this is the limit. I haven't taken it yet. Of x approaches 4. Square root of x times square root of x is x. Then I get two terms that cancel. When I multiply minus 2 times square root of x, and then just square root of x times 2, and combine those, they add up to 0, because they cancel. Minus 2 square root of x plus 2 square root of x is 0. Then I have the term I get from multiplying negative 2 times 2. That'd be minus 4. All right, in the denominator, I'm going to leave this alone. I have an x minus 4 and times square root of x plus 2. Okay, so now both have a factor of x minus 4, and we can cancel it. Okay, there's a hole in the graph there, but that doesn't affect the limit. So the limit as x approaches 4 of 1. When I cancel the factor x minus 4, I'm left with 1. And I have a square root of x plus 2. Now, this is a simplified version of what we started with. And now as x approaches 4, there's not a problem. As we substitute 4 into square root of x, we get square root of 4, which is 2, plus 2 gives me this, 1 over 4. Wow, that's pretty epic. But after you do 1 or 2, it's not so bad. Okay, let's practice this. So I'm going to multiply the top and bottom here by the conjugate. The reason why is the numerator and the denominator are going to 0. So when I plug in 3 plus 1 is 4, square root of 2 of that is 2, and 2 minus 2 is 0. When I plug in 3 in the denominator, I get 0. So here we go. We're going to multiply by the conjugate. All of this times the square root of x plus 1 plus 2. That's outside the square root. Over the same thing. Square root of x plus 1 plus 2. Okay, now this trick is going to happen again where the square root terms cancel. we'll see that. So this is the limit as x approaches 3. Okay, here we go. Square root of x plus 1 times square root of x plus 1 is just x plus 1. And then the square root parts cancel again, because when we do this one, minus 2 times square root of x plus 1, and then we do this outer one, positive 2 times square root of x plus 1, they cancel. We're left with minus 2 times 2 is minus 4. All over, well, we have this crazy denominator, x minus 3 times square root of x plus 1 plus 2. Okay, we can simplify a little bit. So this is equal to the limit as x approaches 3 of x minus 3 in the numerator, and that's a parentheses there, and x minus 3 times square root of x plus 1 plus 2. Wow. The x minus 3's cancel, so we have the limit as x approaches 3 of 1 over this guy, which is still left. Now, that's a lot nicer. When we put in 3, the denominator is not going to 0 anymore. When we substitute 3, this is what we get. 1 over square root of 3 plus 1 plus 2. This is 4. The square root is 2. So, when we simplify the bottom, we just get 1/4. Okay, let's try another one. We're getting on a roll here. So we're going to multiply that by the conjugate. That would be square root of x minus 2. It's this sign I need to change. Plus 3 over the same thing. All right, here we go. This is the limit as x approaches 11. This times this is x minus 2. The inner and outer terms cancel if we multiply that out. And we just have minus 9 over, we're going to have, I'll write this term first, square root of x minus 2 plus 3 times x minus 11. Sorry, I just kind of wrote these backwards. Okay, equals the limit as x approaches 11 of x minus 11 over square root of x minus 2 plus 3 times x minus 11. Cancel those. We have the limit as x approaches 11 of 1 over square root of x minus 2 plus 3. Wow, when I put in 11, that's the square root of 9, which is 3. 3 plus 3 is 6. This is 1/6. I bet you didn't expect to be doing this when you woke up for breakfast this morning. All right, I got one more. This is just I picked this one because it's slightly different. Same technique. We wanted to rationalize the numerator. That means get rid of the square root part. And we do that by multiplying by the conjugate. So as x approaches 0, the numerator is approaching square root of 2 minus square root of 2, which is 0. The denominator is approaching 0. Here we go. Multiply by the conjugate. So this is going to be the square root of 2 plus square root of 2 minus x all over the same thing. Now, multiply the first. We get the limit as x approaches 0. We still need that. We're working on that. So square root of 2 times square root of 2 is 2. Again, the inner, when I multiply that mess, is the opposite of what I get when I multiply those. So those cancel. All right, and then I got to do the last. This times this would be minus 2 minus x. Because the square root of 2 minus x times square root of 2 minus x is 2 minus x. I got to be careful because there's a negative here. All right, divided by x times square root of 2 plus square root of 2 minus x. Okay, simplify, and hopefully we're almost done. 2 minus 2 is 0, minus and minus x is x. Oh, I see what's going to cancel now. Square root of 2 plus square root of 2 minus x. Those cancel. And I get the limit as x approaches 0 of 1 over square root of 2 plus square root of 2 minus x. Now, this is not going to 0 anymore. So if I put in just 0, I get 1 over square root of 2 plus square root of 2, which is 1 over 2 square root of 2. Okay, I'm going to leave it like that. All right, so, wow, these are nice, juicy calculus problems. They involve a little bit of work. All right, but once you practice it and you start getting these right, it feels good. Okay, I got 3 problems for you. So the first 2, pretty standard problems. On the first one, you have to rationalize the numerator. That matches the examples we did. On number 2, it's the denominator we got to rationalize. So you have to multiply by square root of x plus 4 on top and bottom like this. All right. And then the square roots are going to cancel in the denominator this time. And try this last one. Okay, so write these in your journal book. Ask me questions in class if you got them. Take care.